Today we're going to be looking at graphing different types of parent functions. Does it say graphing parent functions on your notes? I don't remember if I changed it after. No, right here under Unit 3. It should say parents. If it doesn't say parent functions, just add that in there. Graphing parent functions. Okay, so graphing parent functions is what it should say. Alright, so like I said yesterday, we learned a way how to express domain and range when you were just given a list of points, and then all you do is list your x values for the domain and list the y values for the range. When we're dealing with graphs, it's going to be a little bit different. Domain still deals with all the x values, though. But when we're dealing with graphing, a graph covers intervals of x and y values instead of just specific points, because there's a continuous line connecting all of the points. So a domain represents the interval of x values that the graph spans. And so when we list the domain, we're going to talk in a minute about the interval notation that we're going to use. But you always start with your smallest x value and go to your largest. Or if you want to think about it as furthest left to furthest right. So you go left to right when you're looking at your graph. Thank you. And then the range, the same idea, but with our y value. So for the range, it's the interval of y values that the graph spans. And so range is y values, so that's up and down, and again you go from smallest to largest or lowest to highest. Okay, so when we are writing domain and range for functions, again, we're going to use what's called interval notation. And so how it's different from yesterday. Yesterday we had to list every individual x and every individual y. For this, we just have to write our end points, so the smallest one and the largest one. And then around those values, we need to include or denote if those values are included in the graph or not included. So if we have closed dots or closed points, that means we're included, and we use brackets, square brackets. If we have open points, so they're not colored in, that means not included. And we use parentheses. So it's important that there is a difference between what your bracket looks like and what your parenthesis looks like, because they mean two different things. So make sure your square brackets are square and your parentheses are nice and curved. Okay, sometimes when we are graphing functions, like equations, f of x equals, those graphs don't really have ending points, but they end with arrows on the end because they go on forever. So whenever we're dealing with arrows in any direction, that means we're going towards infinity, either positive or negative infinity. And the infinity sign is like a sideways 8. So it's positive infinity if we're going up or right. And then negative infinity, it's a negative sign in front of it. And that's if we're going down or left. And then arrows always get parentheses. So if you have an arrow, you would have infinity with a parenthesis. You can't put a bracket on infinity because infinity is not a number. It's telling you that it's going on forever. There is no bound to it. That is the weirdest P I've ever drawn in my life. All right, parenthesis. Okay, so the only time you use the square brackets is if your graph stops and it's a closed point. Everything else is going to be parentheses. Okay, so if we look at example 1a, we have our graph. So we don't have any arrows. This is where it just has a stopping point on each side. So our domain is dealing with our x values. And we go from left to right. So looking at our graph, the furthest left our graph goes is -3. And the furthest right our graph goes is 1. Again, you have to have it in terms of x values. I don't care about what the y value is at that point. I just care about the x value. So now we just have to figure out if we're going to use parentheses or brackets for these. So when we had our point over here at x equals -3, that is a open point, which means we use a parenthesis. So we'd have a parenthesis with our -3. And then our point at x equals 1 is a closed point. It's filled in, so that one gets a bracket. Okay, and again, there has to be a clear difference between what your parentheses look like and what your brackets look like. All right. Any questions there? And just to make sure that you have the right values, it is helpful sometimes to draw these lines, because then if you have any part of your graph outside of these lines that you drew, that means your domain should go further than what you have. Okay, then if we do our range, so range we always go from low to high. So the lowest our graph goes is... so the lowest our graph goes is the y value of -4. Because again, we're dealing with only the y values. I don't care about the x values. And then the highest my graph goes is the point, the y value of 0. So lowest y value to highest y value. Okay. So if we look at the lowest y value, it hits that y value of -4 a couple times, right here and right here. And both times those points are included. This line is a solid line. There's not a hole in the middle, and that is a closed dot. So -4 gets a bracket. And then 0, when we go up, again, there are two different points where that 0 is hit, right here and right there. So even though this one is an open dot, and that would usually mean a parenthesis, since we have another point that is included at y equals 0, because that's a continuous line, then this would be included because there is a y value of 0 that is included in this graph. So this one gets a bracket as well. All right, let's try letter B. So domain. The furthest left our graph goes is, the x value of 0. Would it get a bracket or a parenthesis? Bracket, because it's a closed dot. And then what's the furthest right our graph goes? Infinity. Yeah, we have this arrow that's pointing off to the right, which gives us a positive infinity to the right because our x values are going positive when you go to the right. So we would have to positive infinity, and infinities always get parentheses. Okay, then with our range, what's the lowest this graph is going? Negative infinity, yeah, because this arrow is going down and to the right, and so this arrow is going down forever. There's not going to be a definite stopping point. So our lowest that our graph goes is negative infinity, because when you go down on a graph, that's where your negative y values are. And infinities always get parentheses. And then the highest our graph goes is the y value of 0. And again, that's a closed dot, so we get a bracket. Okay. Do you guys have any questions? Yeah. No, there's not really a typical domain or a typical range. We are going to talk about some parent functions in a minute, and those have specific trends that are the same for all those types of functions. But when it's just like this, when we're just kind of drawing lines with open and closed holes, there's no typical ones. You just got to look. Yep. Any other questions? Okay, can you guys try C and D then? Go ahead and try C and D. We're doing the domain and range with that interval notation. We'll go over it in a second. All right, so for letter C, whenever you see arrows, it's good to kind of just take a look at those first and see what they're doing. So this arrow right here is going up and to the right. And this arrow down here is going down and to the right. Oops. Down and right. So it's just good to have that information before you start trying to do all your domain or range, but I mean, you don't have to do that if you don't want to. So when we do our domain, the furthest left this graph goes is right here, the x value of 0. And again, it's just a continuous line of the graph. There's no open point in the middle there, so that is included. So you would use a bracket and the x value of 0. Then if we look at our arrows, we have both of our arrows are going to the right forever, which means we're going towards positive infinity when we go to the right. So we'd have 0, comma, infinity. If you want to write the plus sign for positive in front, you can, but if you just have an infinity, that's implied positive. And then infinities always get parentheses. Okay, and then for our range, so we have one arrow that's going down forever, that's going to negative infinity. And we have one arrow that's going up forever, that's going to positive infinity. So that is going to be our range. There is no stopping point when we're going from our lowest y value to our highest y value because it's going down forever and up forever. So our range would just be negative infinity to infinity, both with parentheses. Okay, do you guys have any questions on letter C? Okay, then letter D. We have one arrow here for letter D, so this arrow is going up, which would be a positive infinity, and we're going to the left, which would be a negative infinity. So again, it's just good to know. When we do our domain, so furthest left, we have an arrow that's going to the left forever. So even though there is a stopping point right here on the left side of our graph, this arrow is going even further and is going to the left forever. So arrows always trump any stopping points. So our domain would start with negative infinity because we're going to the left forever, and negative x values are to the left. Infinities always get parentheses. But then when we go to the right, we have a stopping point right here at the x value of 3. That's the furthest right our graph goes. And it's a closed dot, so it gets a bracket. And for the range, the lowest our graph goes is down here, this y value of -3. 1, 2, 3, yeah. Y value of -3, and it's a closed dot, so it gets a bracket. But then we have this arrow up here that's going up forever. So the highest this graph will go is a positive infinity. So as we go up, our y values go positive. And infinities always get parentheses. All right. Any questions here? Yeah. Well, you always go lowest to highest. So the lowest is negative infinity. The highest is positive infinity.
If I put infinity,
that would be wrong. Right. Yep. All right. So on the next page, we're going to be talking about different functions, and what we're going to be talking about here are called parent functions. When we move on in this unit next week, we are going to be doing transformations. It's going to be some fun stuff, but we're going to be mainly transforming these parent functions. So this is like the original function, the function that has the least amount of addition and multiplication going on. It's just the basic form of all of these functions. So a parent linear function has the equation just y equals x, just a plain old x, or again we can use our function notation, f of x equals x. So a linear function just has a plain old x, there's no exponents on the x, no crazy, you're not dividing by x, there's no square root symbols or anything, it's just an x is the only thing that's happening. So in your calculator, we have to be able to graph all of these different parent functions, so if you can all get your calculators out. And then hit your y equals button in that top left corner right under the screen. If you have any equations in those y1, y2, just go ahead and clear those. And then in order to type in y equals x, it already has the y equals for you. You just have to hit the x button. Can I borrow yours for a second? And so for x, again, remember we use this button right below mode that says like x, t, theta, n on it. That's the key you use for x. So you just type that x. That's all you got to do. Make sure at the very top that all your plots are unhighlighted. We're not doing scatter plots anymore, so make sure those are unhighlighted. Just hit the up arrow and enter over them to unhighlight them. Then once you have y equals x plugged in, if you just hit graph, it should graph a line. Hopefully one that looks like this. Oops, that's a bad straight line. Okay, so lines, as we learned when we were graphing them in the last unit, they can look different, right? We can move them, they can have different y-intercepts, they can have different slopes, but this is the most basic linear function, just y equals x, where it has a y-intercept of 0 and a slope of positive 1. So when we have a graph of a line, we will always have one arrow pointing up forever, one arrow pointing down forever, and one arrow will always be going to the left forever, and one will be going to the right forever. It might not always be down and left and up and right, but there will be one of each somewhere, just depending on the slope. And so because of that, when we are talking about domain and range of linear functions, the domain is going to be negative infinity to infinity because we're going left forever and right forever. And our range will be negative infinity to infinity. This will be true for any linear function. Okay, so if your equation or if your graph is a line, it's just a straight line, then it will have a domain of negative infinity to infinity and a range of negative infinity to infinity. Okay, our next parent function is the square root function. So this has the equation y equals, and then we have the square root symbol, square root of x, or again using our function notation, f of x equals square root of x. So if you go back to y equals in your calculator, so go ahead and hit y equals, and clear what you have there, your x from y equals x. To get this square root symbol, you gotta hit the second button, and then the x squared key, which is below second. So you get second x squared. That will give you the square root symbol, and then you'll type in the x in that symbol. Okay, so the square root parent graph. If you guys will actually look at the table for a second, hit second graph, you'll see that at some point in the table your y value is saying error. That is because with square roots we can't take the square roots of negative numbers, so any x values that would cause that value under the square root to be negative would give you an error. So because of that, a square root function has a definite starting point. For the parent function, it starts right at the origin. You can also look at your table to get some points as well. So it has that point 0, 0. Another nice point is the point 1, 1. Another nice one is 4, 2. And 9, 3. So you can use your table to help you graph. You can just pick out the nice points. You don't have to worry about graphing like the 1.14, 7, 8, 9. And then we connect our dots. And it's important with square roots, again, that it looks like your graph in your calculator. So if you hit the graph button again, whatever you sketched on your paper should look like what you have in the calculator. So it has a starting point, so you can't extend your line further. It doesn't go that way. It stops right there. And then you have your arrow going off to the right there. Yes? If you hit second graph, you can look at the table. Okay, so the domain of the parent function of the square root function, we have the furthest left it goes is the x value of 0, but then it's going right forever. So it'll be 0 with a bracket because it's a closed dot to positive infinity, and infinities always get parentheses. And then the range, the lowest we're going is the y value of 0. But then this arrow is going up forever. It's not going up very quickly, but it is going up. So it's going up to positive infinity. Yeah. Okay, so domain and range of square root functions. The numbers that go here and the order of like the infinities and the stopping points will vary just based on how your square root is, which way it's facing. But in general, you will always have, so it will vary in order and sign, but you will always have one actual number because it has that one stopping point here. So you will always have one number and either a positive or negative infinity for each. So your domain and range will each have a number and an infinity. Just the order and the signs that they all come in will vary with the different equations that we're dealing with. Okay, so you have to be able to identify square root graphs. So it's kind of that little arch shape. Our next parent function is the quadratic, which is y equals x squared, or again with our function notation, f of x equals x squared. So to get the squared in your calculator, if you go back to y equals, and then clear what you have, clear your square root function that you have there. You would type your x, so hit that x, t, theta, n key under mode. And then to get the square symbol, there is an x squared key in your calculator underneath second. If you hit that, it'll put the squared up for you. So you type x, and then you hit x squared, and it'll square it. And then if you hit graph and look at the graph, it should be a U shape. And if you hit second graph, you can look at the table to get some specific points. So 0, 0 should be one of them, 1, 1, and negative 1, 1, 2, 4, and negative 2, 4, and 3, 9, and negative 3, 9. So using your table, you have to make sure that you are getting points that actually will make it look like your U. You have to make sure that once you are connecting your dots, it looks like what you have on the graph in your calculator. So it should have this U shape. So it's a U shape. This is also called a parabola. Okay, so quadratic functions will always have this U shape. They might be facing different ways, but it will always be shaped like a U. So the domain of the parent function, we have an arrow going to the left forever and an arrow going to the right forever. So it'll be negative infinity to infinity. This will be the same for any quadratic. You will always have an arrow going to the left and an arrow going to the right. And then the range, the lowest it goes is the y value of 0, and it's included, so it gets a bracket. And then our arrows are going up forever, so it's going up towards positive infinity. So again, the range will always have a number and an infinity, just depending on if your parabola is opening up or if it's opening down. Sometimes it'll be negative infinity to a number, or here it'll be a number to infinity. So we'll have a number and a positive or negative infinity. Okay, then our last parent function is absolute value. If you guys remember, absolute value is these vertical bars, and it's asking how far a number is from 0. So the function is y equals the absolute value of x, or if we want to use our function notation, f of x equals the absolute value of x. So in the calculator, this one's a little bit, you have to push a little bit more buttons to get this. But hit your y equals and clear your quadratic equation. Then to get these absolute value bars, if you hit the math key underneath second and then go over to NUM, then it's that first option, ABS with a parenthesis. So again, you hit math, go over to NUM, and it's the first option, ABS with a parenthesis. So you'd hit enter, select that option 1. So you'd have ABS parenthesis, and then you type in your x, and then close your parenthesis, and that is how you get the absolute value. So some calculators, it'll actually show you the actual bars, but some it just says ABS, but that means absolute value. Okay, then if you hit the graph button, you can see what it looks like. It should look like a V. So if you look at your table to get some points, make sure that you're getting enough points to get that V shape out of it. And connect your lines. Okay, absolute value is different than the parabola. The parabola is nice and curved and rounded, like the quadratic. Absolute value is pointy. It's a V, not a U. So absolute values are V-shaped. The domain and range, though, it's the same idea as with quadratic. We'll always have an arrow that's going to the left. We'll always have an arrow that's going to the right. So domain is negative infinity to infinity. And it's the same for all absolute value. And then the range just depends on which way it's facing, but it will always have a number and it will always have an infinity. So in this case, the lowest our graph goes is the y value of 0, and then it's going up forever. So we'd have 0 with a bracket to positive infinity. Okay, we're going to be dealing with these parent functions a lot, these 4 functions: linear, square root, quadratic, and absolute value, so make sure you're familiar with them. So we go on to the next page. The easiest way to graph parent function or to graph functions is by using a table of values and by using your calculator. You have a graphing calculator, use it to your advantage. So I just want to go through these examples first and say what the general shape should be, and then I'll let you guys plug it into the calculator. So if we have example 1, we have f of x equals 2x plus 4. What of those 4 functions, what type of function is this? Does it have the absolute value bars? No, it's not absolute value. Does it have a squared? No, so it's not quadratic. Does it have a square root symbol? No, so it's not square root. So that means it must be linear. It just has a plain old x. This is a linear function, which means its shape should be a straight line. Okay, so when you're graphing the function, you got to make sure it looks like a straight line. Example 2, what type of function is this? What's this little 2 mean that's outside the parentheses? Squared, which means it's a quadratic. And a quadratic graph has a U shape, so you want to make sure that when you're graphing on your calculator, your graph that you sketch on your notes looks like a U. Okay, what about example 3? What type of function is this one? Absolute value, because it has these absolute value bars here. And absolute value graphs look like a V. And then what about example 4? Square root, because it has a square root symbol. And a square root graph has a starting point, and then it has a little arch that goes off. Okay, so I want you guys to practice typing these in your calculator. Be careful with parentheses. So like example 2, type it in exactly as you see it. With example 3, when you have your absolute value, you would have your ABS parenthesis x. Then you have to close that parenthesis before you can do the plus 3. And same thing with example 4. You would have your negative square root. I think sometimes it pops up with a parenthesis. X minus 3, close the parenthesis before you plus 2. So be very careful with parentheses. Go ahead and try to graph these 4 functions and then sketch those on your paper. Use your table to help. All right, let's take a look at these. So for the first one, it was just a straight line. So you could have graphed this without your calculator too, hopefully, because this is what our last unit was. But if you just type it in your calculator next to y1, you would have just 2x and then plus 4. Again, use that x, t, theta, n key to get that x value. And once you look at your table, once you look at your graph on the calculator, you should have ended up with a line here with a y-intercept of 4 and a slope of 2. Any questions on how to get the graph? Okay, and then domain and range. Remember, for all lines, your domain is negative infinity to infinity, and your range is negative infinity to infinity for all linear functions. Okay, for the quadratic, you should have, again, typed in x minus 3, close the parentheses, and then hit the x squared button to get that squared outside of the parentheses. And looking at the graph and your table, you should have ended up with your parabola just scooched over a little bit. So it should have the vertex or the bottom of the parabola at the point 0, 3. Then it goes up from there. Any questions about that one? Okay. Then with quadratics, remember the domain is always negative infinity to infinity. Always. Because we have an arrow going to the left and an arrow going to the right. And then our range, we have a lowest point, which is the y value of 0, and then it's going up forever with those two arrows. So it'd be 0 with a bracket to positive infinity. Okay, example 3. Again, you have to make sure you close those parentheses with the absolute value before you add 3. So your graph should have just moved up 3. And then the domain, again, is always negative infinity to infinity because we'll always have an arrow going to the left and right. And then the range, the lowest this graph goes is the y value of 3. Then it's going up forever. So it should be 3 to infinity. Okay. And then example 4. Just being careful with parentheses, again, making sure it's closed after the square root before you add the 2 at the end. Make sure you use the negative sign, not the subtraction sign, or else your calculator would freak out. So our square root graph is kind of flipped and it's moved over and up. So when we are looking at our domain, the furthest left it goes is the x value of 3, and it's included. But then it's going right forever, so it goes to positive infinity. And then for the range, this arrow is going down and to the right, so the lowest it goes is negative infinity. Then the highest it goes is that starting point there, which is at the y value of 2. All right, so really you just have to be able to use your calculator. If you can type these equations into your calculator, the graphing will be pretty easy because it's telling you exactly what you have to do. All right.